All right. Thank you all for coming to my talk. Thank you for my attention. Thank you for your attention. I'm super excited to be here. It's been a blast so far, and New Zealand has been a really great host for us. So thank you all. In 2016, when I graduated from university, I was just an insect behaviorist looking for a problem to solve. And then I got introduced to the mushroom industry. And I've been met with nothing but problems to solve since. So I think it's pretty stable for me here. So I'd be remiss without introducing, a lot of this work is done by my mushroom fly research team, which I'm the lead of, and I'm really happy to present all of our work. So mushroom flies in Pennsylvania, I'm sure you've got them on your farm too. We have lots and lots of phorid flies on our farms, but we also have a fair bit of Sierrids. This is what we see. They're all over the walls. They're all over the doors. When we open the doors and we apply glue to the doors, they get stuck on there. And then, I don't know if you can all see this video on the right. It's not snowing there. Those are all phorid flies forming a mating swarm outside of a spawn run room. And we'll get into why that happens. But most problematically, this is what we see on our harvest mushrooms. It's real around this time of year. October, November is the peak fly season. It's really, this is not uncommon in Pennsylvania, in Kennett Square around this time. When I was at our conference 2 weeks ago, nobody admitted to having flies like this. So, when I ask, who doesn't want to comment on the flies on their farm, and that's when I get the hands up. So that's when I know that's what we see. So flies, they vector disease. It can take a perfectly good flush of mushrooms and make it look like that. And that's what we see, again, around this time in Pennsylvania, because the flies can vector disease terribly. The growers lose between 10 to 40% of their crop around now. So my job exists also to serve the community members living near mushroom farms, because in Pennsylvania, the mushroom farms were there first, communities were built later, and let's say you have 600 million flies in a growing room, it doesn't take much of a leak for people to have 10,000 flies in their kitchen. And when that happens, that's when the pitchforks came out, and so that's why my job exists. My job exists to suppress mushroom fly populations on farms. We do this by testing new methods in the lab. That's actually the easy part. The hard part is finding new methods or coming up with new methods, technologies, and products to test. Then once we find things that look really good in the lab, we bring those out to the field and we do significant field testing. And then finally, it's also my job to facilitate the adoption of the new methods. Okay, so I just don't stop once we find something that works in the lab, and I don't stop after our field trials. I want the entire industry to use what we have, because that is essentially the problem, right? Because my goal is to suppress the fly populations on the farms, and that doesn't happen if I don't sort of pitch it to the industry to use what we come up with. There's a fair bit of crosstalk between these circles here. So for example, testing new methods and the field trials. If we see that things aren't working in the field, we go back to the lab. We don't give up. We figure out why didn't it work. What's the difference between the lab and the farm? There's major differences, but if we can distill it down to the principles that the previous speaker was talking about, if we understand the principles, we can apply that and make what worked in the lab work in the field, if possible. And so then same thing with facilitating the adoption. If we have a really good method, but it's really difficult for the growers to adopt because it requires additional labor or additional steps, or the pickers will destroy it, or there's any number of reasons why a farm can't implement it, that's important too. And we need to take everything into account when we're developing a method, because it's got to be something that the growers can adopt, and adopt quickly and easily. The flies are our enemies here. I'm an entomologist, but it's my job to kill them. And so I want to start by sort of saying, again, going back to first principles, we have to understand what the fly is doing and why it's doing that in order to effectively stop their life cycle, to effectively kill them. So that's what I want to spend the first bit of the talk talking about. Like I said, I'm an entomologist, so I'm not going to talk at you about the mushroom growing cycle. You know that way better than I do. However, I want to talk to you about the mushroom fly growing cycle, because at least my Pennsylvania farmers around this time of year, they're not growing mushrooms, they're growing flies. They're growing flies in way bigger numbers than they're growing mushrooms. So that's how I want to start this story. Beautiful spawn run here. That's when we have flies invading because they want to, that's where they're going to lay their eggs. During spawn run, during case hold as well. So moving forward, this is what I'm going to call an invader or an invading fly. These are the flies entering the room to lay eggs in the compost. And let's just say we start with 6 flies on your farm, 3 males, 3 females. 1 female phorid fly can lay 50 eggs. 1 female Sierra fly can lay 170 eggs depending on temperature. These are all temperature dependent. And I kind of want to show you what that means. So for example, if we have 3 females, let's say they all get pregnant, and they lay each of their 150 eggs, well, that's what it looks like. There's now 150 eggs in the compost because you have 3 flies, because you have 3 females. As spawn run continues, the eggs hatch and develop. It takes about 1 to 2 days for the eggs to hatch, the larvae to come out, and begin eating the compost. For the phorid flies, they eat the actively growing mycelia. For the Sierra flies, they just need to eat the organic matter in the compost. As spawn run turns to case hold, the larvae pupate in the compost. So this is where they become pupae, and they don't do anything for a while. It's important to note that at this point, if you have an invader, the fly is basically won. We don't have any methods yet to kill phorid flies in compost. So once you have an invader, we say the fly is won. We can't stop them from turning into an adult. So towards the end of first break, middle of second break, or beginning of second break, that's when all of those eggs eventually hatch and they turn into flies, and now you've got a really big problem because you've got flies. These are not flies coming into your room. These are flies that are emerging from your compost. That's why we classify them as emergers. They leave the rooms because phorids especially do not like to mate in the rooms. They prefer to mate outside. They're crepuscular, meaning they need mood lighting. Dawn and dusk is when they prefer to mate. They go outside, and at dawn and dusk, they emerge at all times. They're looking for sunlight to know where outside is. But then the emergers become the next invaders on the farm. That's where your flies are coming from. And here in Pennsylvania, because the farms are so concentrated, they're all sharing their flies. So they're coming from other farms too. They invade the next room, and then instead of 6 flies, you have this many invaders, and the process starts again. And I want to talk about numbers here for a second because this is really important. This is the most shocking part because I can say 1 female lays 50 eggs, or in the case of Sierrids, 1 female lays 170 eggs. But this is what it looks like. So in March, which is when we're going into our springtime, I understand you're going into your springtime now, let's say you only have 2 flies on your farm, only 2, or maybe in a growing room. Say one of those is female, and she's pregnant, and she lays her 50 eggs. Well, the next month, 18 to 22 days later, you've got 50 flies. Let's say half of those are pregnant females, and they lay their eggs. Well, that becomes 1,200 in the 3rd month. And that becomes 31,000 in the 4th month. And let's say half of those are female. Well, that becomes 781,000 flies. In the next month, we're already in 19 million flies. 488 million flies the month after that. And now I think we're in the trillions. And that's where we are right now. And that all starts from 2 flies in early spring. So that's what exponential growth looks like. And this is the slide that gets taken pictures of the most by the farmers. But I think this is really powerful because in the first 2 months, when you don't have very many flies, killing these early flies prevents all of these flies from occurring. So preventative, because killing just a handful of flies in the first 2 months is killing trillions or billions of flies later in the season. And again, 1 Sierrid lays 170 eggs depending on temperature. So triple these numbers if you have got Sierrids on your farm. So I'm an insect behaviorist. I wanted to solve this problem using insect behavior. we developed attract and kill stations to try to kill the emergers as they were emerging from the compost. We know they want to go outside. We know they're attracted to the sunlight. So we thought, what if we use a trap that is based on the sunlight coming into the farm? So we use these electrostatic screens. Growers applied pesticide to the electrostatic screens. These were the results of the 2021 experiments, where the dots in red are the farmers that weren't using the technology yet. The dots in black are the farms that were using the technology. It worked really well. Here's the averages here. The red line is taller than the black line, meaning that there were far fewer, significantly fewer flies on farms that used our technology compared to those who don't. This is a really cool graph, but I think the pictures are even cooler and the videos. So this is what an attract and kill station looked like before we applied the pesticide to it. And then after we applied the pesticide, this is what it looked like, where I call this a fly graveyard, where I'm about to stick my finger just to show how deep the dead flies are. So it killed about 1.5 million flies in 24 hours. And like I said, if one female lays 50 eggs, that's 37.7 eggs that did not get laid, all from one attract and kill station in one room on one farm. And this farm in particular has about 50 to 60 rooms, something like that. So that gives you an idea of the scale of forage that we have in Kennett Square. And then it all fades to black because for whatever reason, the company making the electrostatic screens, which is really important, went out of business. Or I don't know if they went out of business, they disappeared. We can't buy the screens anymore, and I had to pivot my entire program. So that's what I'm going to talk about today. That was all sort of introduction to me and my methods and how I like to do things. And particularly, I want to focus on the two things on your right, my left, the nematodes and the predatory mites. Biologicals. I think biological control is the way to go here. We're in a controlled climate agricultural system, perfect for biologicals that like that kind of thing. Amy McKinnon's going to be talking about her biologicals. I'm sure it's going to be a fantastic talk, and I'm going to do some of the heavy lifting on why I think biologicals are going to be great on your farm. Let's talk about, I'm not going to talk about the monitoring or the mass trapping or insecticides as much if I have time, probably not at the end. Let's focus on nematodes first. What are nematodes? Nematodes are transparent roundworms. The ones that we work with are nearly microscopic. You can just see them with your eyes. They range in size between like 8 meters long, or they can be, most of the ones that we work with are about the size of a thickness of a human hair. There's 30,000 species that have been described, and we think that over 1 million species exist. And it's one of the most abundant animals on Earth, mostly found in soil. About 118 of these species specialize in killing insects, specifically in soil and compost. And 14 of these species are commercially available for use right now. And you can buy them here in Australia and New Zealand. They're available. Here's just a list of some of them. I'd like to point out that Sierrid flies can be, we already know that Sierrid flies larvae can be controlled using Steinernema feltiae nematodes. They couldn't be used to control phorids, and we didn't know why. But we're looking at a new species of Steinernema now, Steinernema carpocapsae. They look exactly the same to our eye, but it really makes a big difference. So our questions are, if we're looking at this new species here, carpocapsae, it's a little bit smaller. Do nematodes kill mushroom flies in the compost? How long do nematodes live in the compost? And essentially the big question here, which we're building up to, is can we see reductions in mushroom fly populations in field experiments using nematodes? Bottom line up front, because not everybody loves graphs and statistics and things like that, yes. I don't know if you can see that behind the chairs. Yes, these things work, and they reduce the flies on farms. But I'm going to show you how we figured that out, because I think that's really important. And on the right here are the fantastic students that did the work or are doing the work. So I want to give everybody credit. It's not just me. It's, like I said, it's a mushroom fly research team. So do the nematodes kill flies in the compost? Well, what we did was we took these tubes here, and we added 5 larvae to compost. We cased it. and then we added the treatment. The treatment could be nothing, the treatment could be nematodes, and the treatment could be just water. Nematodes are watered on just like the watermen do in casing. So it's not much more labor. All it is adding a pack of nematodes to the water when your watermen do it. Like I said, we've got the 3 treatments here. And then we incubated the tubes for 3 days, 72 hours. And the larvae were then recovered, and we saw which ones died. Simple experiment. On the y-axis here, we've got average mortality, so the percent that were killed by nematodes, because we did check that, and I'll show you what that looks like also. And on the x-axis, we've got the treatment, whether it was a control, whether it was just water, or whether it was water with the nematodes in it. This is what the graph looks like. 41% of the larvae were killed by the nematodes, and we thought that was really exciting, because if you can kill 41% of your larvae with a biological, this is not a pesticide, this is another animal that you're adding to your compost that is normally there. The pasteurization removes the nematodes that would have been there, so you're just re-adding in some of that biology that isn't there anymore because it's because of phase 1. So this is a really cool graph, but I like pictures, I like videos, because then you can really see the science that's happening. So here is a phorid fly that died of natural causes. You can see it's got different organs and stuff in it. It's got fat bodies, but there's not a lot moving in there because it's dead. If we look at this picture, this video, this is what we call, it might be tough to see, we call spaghetti strands moving around in there. Those are all nematodes that have become adults, and they're about to burst out because that is no longer a phorid larva. That's just a sack of nematodes. They've infected this thing, they've killed it with bacteria, and it's about to burst. Oh no, that looks terrible. Well, this is what, on the bottom video, is what it looks like after a larva has burst because it's got too many nematodes in it. So that one on the top, you can kind of see little spaghetti strands on the outside of the larva. That's one trying to get in, and there are some nematodes inside, but yeah, this is super cool. This is what is killing the larvae. So then, you know, we could have packed up and said, all right, well, we know it works, we know it kills them, let's move on to something else. 41% is a really good like bomb application to give to the compost. But then we talked to the growers, and they weren't seeing any fly reductions on their farms, even though they were using the nematodes the way that the manufacturer recommended. However, the manufacturer did not know much about mushroom farming, and their recommendation, we're not quite sure where it came from. So we wanted to go back to the lab, figure out, well, why didn't that work? And that's what I was talking about here is, okay, we weren't even doing field trials yet. We were just doing pilots just to see, does this work, yes or no? The manufacturer recommended 1 application at casehold, and we wanted to know if that's enough. So we asked the question. We added a known number of living nematodes to the compost. Every day for 10 days, the nematodes were washed from the compost. We recollected them, and the students counted how many of them were still alive. That's a lot of hours at a microscope. We recorded the percent recovery of the living nematodes. So on the y-axis here, you'll see the average percent of living nematodes that they recovered. And on the x-axis here, you'll see the number of days. And what you'll see is that 50% of the nematodes died 4 to 5 days after application. So for whatever reason, these nematodes are not living as long in the mushroom compost as the manufacturer expected, as we were expecting. So what that means is nematodes may need to be reapplied every 4 to 5 days to achieve proper control. So what we decided we were going to test this in the field and do 4 pairs of rooms between 2023 and 2024. This is still going on right now. Do a double application right before casehold. Double application is 1 billion nematodes. 500 million nematodes is a normal application. So, and then 500 million nematodes every 4 or 5 days through casehold until we get, after first break, then we throw in another billion and see if we achieve any control. We collected fly counts because monitoring is really important to understand the fly populations. You can't control what you can't measure, so we're trying to measure as much as we can. Think about controlling your compost. If you're not measuring your compost, you're not going to have good control over it. We observed fly reduction on the farms, and we observed the ratio of emergers to invaders. This is how we were trying to understand if we were killing the larvae. So we know how many invaders came in. The invaders, like I said, have already won. They lay their eggs. The larvae come out. And this is what we're trying to see is, are we able to have fewer emergers than we would expect based on the invaders? So here's an example of pair 1 in 2023. In 2023, in pair 1, with the orange dot, that's our nematode room. The blue dot is the control room, didn't get any nematodes. And you can see that there were 250% more invaders in the nematode room compared to the control room. We have no control over that, so we were curious what we'd see, because there were 2.5 times more flies coming into the nematode room than there were the control. For whatever reason, maybe somebody left a door open or something like that. And what we saw was really cool, where there were 31 fewer emergers per day in the nematode room, 31% in the nematode room compared to the control room. So this orange line is relatively flat compared to the blue one. The blue one has a lot more emergers compared to the orange one. And if we look at that across all 4 of our pairs, this green line is laboratory mortality. So if what exactly was happening in the lab is happening in the field, we would expect it to be around 41% reduction. And that's not what we saw. We saw a pretty good reduction here. This is pair 1 all the way on the left. They're hovering around the 41% mortality, but I'd like to point out that pair 4, even though it looks low, that's still a 20% reduction of flies. So it depends what your benchmarks are. This is the first year that we're doing. This is the second year that we're doing these tests. We're still optimizing them, but I think these biologicals are a really good start. The nematodes were able to reduce the number of emerging flies in the compost, and this is the first intervention that reduced phorid larvae in the compost. So we're really happy with this. This is the first time. So in summary, do these nematodes kill the mushroom phorids? Yes, they do. What's the downside? Well, you need to apply them every 4 or 5 days, but at least it's not a pesticide. It's a natural enemy. Do they reduce populations on farms? Yes, they did. And the growers were very happy, the growers that participated in this study. Moving on to my next one, predatory mites. Let's talk about mites for a second. What are predatory mites, or really what aren't they, is really what I want to talk about. So we made this GIF in my lab. This is a predatory mite here. So it's about the size of a 0 on a penny. The mites that you have on your farms that are causing damage are closer to this size. They're Tyrophagus. And you can see that this predatory mite is just ripping some organ or innard piece out of a fly larva. And that's what they do. These predatory mites are hunters. They're small predatory arthropods that feed on soil-dwelling insects and mites. So they eat the mites that you have in your compost as well. They're not just insect hunting specialists. They also love eating mites also. These are not the mold mites you see on your farms. In fact, they'll eat them too. They're carnivores, meaning they only eat animals that are moving in the compost. They don't have eyes. They hunt by vibration. If they feel something walking by, they're going to go and kill it. So we've done studies to show that, or to learn, not to show. We've done studies to learn that the mites will kill a larva, run over and kill another one if they feel it walking by, run over and kill a third if they feel it walking by. These things are hunters, and they'll run in between their different preys. They just love to kill. Interestingly, they're repelled by light. Like I said, they don't have eyes, but they do have a primitive eye called nocelli, and that just is yes or no, is there light around? They use that where if they detect light, they go deeper into the compost. What that means is you don't have to worry about these mites being around when you're picking, because if your picking lights are on, they're going to dig down into the compost and stay away from that light if at all possible. They're used in other crops to kill cearid larvae. And our questions were, do predatory mites kill phorid larvae? We thought they would because, again, they're just hunting by vibration alone. We want to know if they were safe, so we asked a couple of questions. Do predatory mites damage the growing mycelium? Do the feeder mites they're shipped with kill the growing mycelium? And do they spread disease? Essentially, are they safe to use? Because I can't recommend them to growers if they're not safe. Again, bottom line up front, we're pretty sure they're safe. And I'll show you why I think that. So do predatory mites kill phorid larvae? We've made a bunch of these paired tubes, as you saw earlier. We added mites to the tubes with fly larvae in different ratios, 3 mites to 10 larvae, 3 mites to 20 larvae, and then 1 mite to 20 larvae. We incubated the tubes for 3 days, and then we recorded the mortality for each pair of tubes. So here's another of these graphs here. On the y-axis, you'll see larval mortality. On the x-axis, you'll see our treatments. And this is what we saw. When 3 mites were presented with 10 larvae, we got, I think it was like 90-something% kill. But I think, so the answer, do they kill phorid larvae? Yes, they do. Many of them in only 3 days. In fact, 1 mite kills about 11 and a half larvae in only 3 days. So like I said, they're voracious predators. The mites are really small compared to the larvae. They're just moving around the soil, killing larvae and other arthropods. So now we need to move on to the more pressing questions. Are they safe to use? Let's focus on, do they damage the mycelium? Because that's a really important thing. These mites are walking around all of the time. So we took these tubes, we added spawn to the bottom, and we added 6 mites, either predatory or feeder mites. We added supplemented compost to the top. We incubated the tubes, and then we recorded the mycelial growth every other day. So as the mycelia made its way up towards the top of the tube, we wanted to see, do the mites slow the mycelial growth at all? So on the y-axis here is the amount of growth that we get. On the x-axis is over time. The red line is no mites. The green line is mold mites. The blue line is predatory mites. And if I'm sharing my predictions, because I want to sort of set up the data, and it's probably a lot I'm throwing at you right now, the control will grow very quickly, get to some top and plateau. If we're seeing the predatory mites interfere with the growth, we think it wouldn't get as high or it would grow slower. And if the mold mites, for some reason, are eating the mycelia, we think the growth wouldn't occur as fast as well, and it also wouldn't get to the same height. And that's not what we saw here. We saw the lines basically around the same, following the same pattern. So this kind of, we were able to draw the conclusion that maybe by a millimeter or 2 on a particular day, but in general, the mites do not damage the mycelia. So then we asked, do the mites spread disease? And I was really nervous about this one because the disease is vectored mechanically, meaning that they just kind of pick it up by accident and drop off the disease by accident. So I thought for sure the mites did spread disease. The way we tested this was we took a petri dish with dry bubble. We're going to redo this with aggressive green mold coming up. We grew a colony of dry bubble in the middle, and then we added a fly or a mite to the petri dish. We allowed the animal to walk around for 24 hours, spreading the spores as it goes. After the 24 hours, we killed the animal where it was, and we let the dish incubate for 1 week to see what grew, if there were new colony-forming units of the dry bubble. We wanted to see if it grew in a pattern also where we could kind of watch a trail of the animal depositing spores here and there. So on the y-axis here is the number of average colonies that were transported by the animal. On the x-axis are the different treatments that we had. So predatory, the fly, predatory mite, mold mite, and then nothing, just our handling, because maybe our handling jostled up some colonies and more. There was more growth there as well. We saw that the fly spread on average 77 colonies in a 24-hour period. We saw that the mite spread on average 4 colonies in a 24-hour period. And we saw the mold mite basically didn't spread very many colonies at all. It was actually less than what we spread when we were jostling the plate around. So we kind of drew from this, are they spreading disease? Not dry bubble. We don't know if they're spreading trike. Our growers are saying that they're not, which is really exciting, but they're the ones in our field studies, but we don't have any data on that yet. So to summarize, the predatory mites are effective hunters. Are they safe to use? They don't damage the mycelia, and they don't spread dry bubble. So, and anecdotally, they don't spread trike either, green mold. So I guess the question becomes mites or nematodes, right? Which one to use? And I think both. I think they work in different ways. So I think the nematodes are easy to water into the compost, similar to a liquid pesticide. So whenever we recommend to our growers to apply them the day before you case, and then every 4 or 5 days, depending on your normal watering schedule, go ahead and add nematodes. And they can provide effective knockdown numbers to when you see invasion. So for example, if somebody leaves a door open, or for whatever reason during casing, you see a huge invasion and you know they're going to lay eggs, that's when you should apply sort of a spot treatment of nematodes. You can do that. You can't really do that with the mites. The mites, however, are really easy to apply early on. We mix it with the supplement so that I think it's 9 bags of supplement that gets mixed into the hopper. Then we add 1 liter of mites. On average, we add a liter of mite per 90 to 100 square meters of growing space. And these mites are cheap, and it's a one-time application, and they provide more sort of stable control as they remain in the compost for 45 days. I didn't show the data, but the mites do remain in the compost when added to a hopper early on, and just eat. We didn't look beyond 45 days. We cut our study at 45 days. All right, moving on quickly. I've got a little bit of time. I want to talk about Vestergaard netting, which is something that I think has the potential to revolutionize fly control in the mushroom industry. Vestergaard long-lasting nets are impregnated with insecticide, so meaning the fabric here on these nets has insecticide in them. Their deltamethrin is the active ingredient, and their different formulations have different accelerants. I just said that. They're currently used right now in Southeast Asia and Africa to kill malaria-causing mosquitoes. People sleep with them in their bed, they drape them over their beds, they touch people constantly. It's a very safe product. We know it kills flies. It's currently going through the EPA registration process in the United States, and it's currently not used in agriculture yet. We are lucky that Vestergaard has chosen the mushroom industry in Pennsylvania to be the first crop to test whether this will work in agriculture. And I really think it will. They've been a great partner with us so far. They also say that these nets last 1 to 3 years in the hostile conditions of Africa, where it's really hot, the sun is baking down on that side kind of thing. And the biggest thing that breaks these nets down is sunlight. But we don't have much of that in the mushroom farms. So I think it'll last maybe close to 1 to 3 years in a mushroom farm. We did some laboratory trials. We added a bunch of flies to some nets. We let them sit there for 5 minutes. We tested the 3 different formulations, side, dual, and roof. They all have deltamethrin, just with a different accelerant or no accelerant. So the flies were able to walk on the nets for 5 minutes. After the 5 minutes, we removed them from the nets, and we watched them for 24 hours. On the y-axis here, percent dead. On the x-axis, the different treatments. And on the y-axis for this one specifically, this is immediately after touching the net for 5 minutes. We observed almost no death. And we thought, well, that's not cool. Maybe we shouldn't use these nets anymore. We looked at them 1 hour later, and it was I don't remember the number, 77% death 1 hour after they touched the net for 5 minutes. This is not an unreasonable amount of time. We tested it for 1 minute exposure as well. It only dropped, it was still above 70%. And then 24 hours later, 92.5% of the flies that touched the net for 5 minutes were dead, compared to the controls, which were closer to 10%. So we're seeing significant mortality after they touched the nets for 5 minutes. This active ingredient here for the roof was deltamethrin plus PBO. We want to ask, how long do they actually last? Can the net survive the steaming? Right now, the holes are too big. They've come up with another, I'll show that later. The flies can walk right through these holes. So there are some problems with it. But we've been testing it over time. I didn't put the month 5 up there. But these nets still remain active 5 months later, which is really important because you can set a net in a growing room and then it remains active. You can just leave it there for 5 months and then you replace it. It's a really good method, I think. Conclusions, deltamethrin was the most effective, 92.5% mortality, the deltamethrin plus the PBO. It was effective for 4 months, now 5. The nets, I didn't show the data, remained effective after steaming, so they were able to survive a steaming, no problem. We haven't tested them after 2 steamings yet. That'll be done yesterday, October 21st is when that test was done. So we'll have that answer. And the question is, can we effectively use these nets on farms? So we've got ongoing field trials right now. We're continuing the longevity studies. We're continuing the steaming studies. And we want to assess whether not only does it kill the flies, but does it also reduce the reproductive output of the flies. So for example, of the flies that aren't killed by the net, they're just exposed to it, maybe they get sick, are they able to still lay as many eggs? And I don't have the data here because it's fresh off of the compost wharf where we tested this. It reduced egg laying by 90%. These nets did. So of the living flies on farms that weren't killed by the nets, those females laid 90% fewer eggs. So if you're a composter and you're producing blocks of compost, that's where we're testing this right now. You can see the blocks of compost in that picture on the bottom left corner. We're designing curtains. We're designing attract and kill stations on picking lights. Any way we can expose the flies to these nets that are away from the grower, so it's pesticide that can't be touched by your workers, we think is a win. Because if we can get the flies to touch this for even 1 or 5 minutes, that's great IPM. The holes are still too big, but ideally, I'd like to use these like we did in my previous test in 2020 and 2021, where I made these fly graveyards to make the same attract and kill stations using these Vestergaard nets. The holes are still too big. The blue one is their first prototype. The black one is their next prototype. The holes are a little bit smaller. We're hoping to get their third prototype where they can actually exclude the flies as well. So it just doesn't kill them, but also it excludes them. And we're really excited to get the third prototype to see if it's just as effective as the first 2. Because if you can add not only killing the flies, but excluding them, that's a win-win-win. The last product is OrganiShield that I like to talk about. It's a very safe product. It's a sucrose octanoate ester. It's an organic biopesticide. The way it works is it dissolves the waxy cuticle of soft-bodied insects. So what it does is it essentially melts their skin away. So if you see this green glow around the insect, that is the outer layer of its skin, and it essentially melts that off of the insect. And then it kills it because it doesn't have its outer layer of skin. What that means, though, it's a physical mode of action, which meaning there's no immune response. They're less likely to develop resistance because you're melting their skin off. It's not like they're going to get sick and produce antibodies or something like that, the insect equivalent. It's currently being used in greenhouses, particularly the hemp and cannabis industry, to kill Sierra flies. And it's an approved contact insecticide in the United States to kill both mites and Sierra flies on mushroom farms. And it can be used basically anywhere because its 2 components, the 2 breakdown parts of it, are really safe. Its 2 components are a sugar, that's the sucrose part, that's breaks down, and it's sugar. The other part is a fatty acid. That's the active ingredient in palm oil. And that's it. Those are the 2 parts to this pesticide. We did laboratory studies where we exposed flies to the OrganiShield. The treatments consisted of different concentrations of OrganiShield. We removed the flies from the OrganiShield after 1 minute. We recorded the mortality. Y-axis again, % flies that were dead. X-axis was the treatments. And immediately after exposure, close to more than 80, close to 100% mortality, or what we thought was mortality, in response to the OrganiShield. Essentially, the takeaway here is all of the application rates of OrganiShield knocked the flies down, However, when we came back and checked them 1 hour later, we noticed that the treatments of less than 2%, 2% and less, the flies reanimated, so they were just knocked down. They weren't killed. It happens. They received a sublethal dose. However, rates higher than 2% was still effective. And then if we take that out to the 24-hour mark, the same conclusions are true. Some flies reanimated after an hour. However, it was very effective after 2%, more than 2%. So the conclusions for this, concentrations of 2.5 to 3% were very effective contact killers at all time points. Organoshield could be an effective fogging option to kill phorids. Again, it can be, if you're monitoring your phorids, you can kill the emergers that way. I also think you can kill you can kill the invaders that way, but you can also kill your emergers if you do this after, right before you steam, because the flies can get out before you steam. So if you kill them before you steam, they won't be able to get out and invade the next room. With that, I'd like to thank all of the funding agencies that have funded the mushroom fly research team. Yes, NASA did fund a student for us. And then all of the members of the mushroom fly research team, my students, my technicians. There's a whole bunch of projects we didn't talk about just because I don't have time. Here is my contact info if you have any questions. I think we're short on time for questions, but take a picture. I'll be around, and thank you for your attention.
One second, Michael. Come back. Yeah, we've got 3 minutes and 25 seconds.
Sure.
So is there any questions from the audience?
Yeah, go ahead.
We've got a couple. We've got Kura with a...
Right now, that's just phorids. The problem with steroids is they might have developed resistance to the deltamethrin, but the PBO accelerant, there shouldn't be resistance there yet. Our lab is currently testing steroids right now, so in a month I'll be able to answer whether or not they kill steroids.
But we haven't used deltamethrin in Australia.
That's great. And it's like I said, these nets, they're not a pesticide application. You can just hang them somewhere where the flies tend to hang out, and hopefully they go there and kill themselves.
We'll get one more here from Robert, and
Sure.
then...
With the nematodes, we tried some, and one of the issues is not wanting to water through pin setting. So have you considered some dead larvae in the system that will keep the nematodes alive longer so that you can, say, span 10 days without watering?
Yeah. So we don't know whether in our tests, we couldn't sort of trust that there would be enough nematodes sort of proliferating themselves to rely on them exclusively if you don't want to water as much during casing. What I will say is that's why the mites are so important, because the mites will always provide a really high base level of control. And I think the nematodes are good as sort of an immediate knockdown to reduce what you've got in your casing in your compost by 40% around then. I think the mites are really important because they will always be working for you for 45 to 60 days.
So thank you, Mike, for your presentation. Just a small...
Thank you.
Just in some more news, Michael is actually visiting Australia in the new year as part of the AMGA managed inbound, outbound study tour program. So Australian growers can look forward to